Hey everyone, it's Melissa here. Let's get this lesson of deductive reasoning underway. Welcome to deductive reasoning as posited by Marzano in Dimensions of Learning. According to Marzano, deductive reasoning is using generalizations and principles to infer unstated conclusions about specific information or situations. Whoa, let's be honest. That kind of sounded intimidating, didn't it? Just think of it this way. Deductive reasoning is when you have general principles that you use to make a conclusion about something specific. The first thing we need to do is make sure that our students understand and feel comfortable with the process of deductive reasoning. We can do this by giving specific examples from everyday life. We may say, this may sound tricky, but have no fear. We use deductive reasoning in our everyday lives. Take, for example, my son Cole. Generalization 1 is Cole wears blue every day at preschool. Generalization 2, Cole will go to preschool on Friday. This can lead us to the conclusion that Cole will wear blue at preschool on Friday. We can share examples with our students such as, you may go to a party and see a delicious looking cake, and you might say to yourself, don't eat that cake because cake often has ingredients that can make me gain weight. You may say to yourself, cacti are plants, and all plants perform photosynthesis. Therefore, cacti perform photosynthesis. It is important that we teach our students to understand how to employ deductive reasoning because it helps them transfer knowledge from one situation to another. If they're able to use appropriate generalizations and do a good job of reasoning, they can have confidence in their conclusion. Take a look at this picture. What general science principle can help your students to deduce that they will fall to the ground if they step off the roof? If you said gravity, you are correct. You may say to your students, which general science principles can help you have the right information related to a specific shot in billiards that can allow you to predict the path of a billiard ball? If they say force and motion, they would be correct. Once students begin to understand how the process of deductive reasoning is used in everyday simple examples, you will want to increase their understanding by clearing up any confusion between deductive and inductive reasoning. For the purposes of this presentation, I will give a very brief definition of inductive reasoning. I noticed that no one signed up for inductive reasoning in our class, so I thought it wouldn't hurt to quickly explain inductive reasoning. Besides, it's very hard to teach deductive reasoning without explaining how it compares and contrasts to inductive reasoning. When you reason inductively, you conclude a general fact based on some specific examples. In this example, a student can use inductive reasoning to make several observations to generate a conclusion. Observation number 1. The number of endangered plants and animal species is on the rise worldwide because of the destruction of their habitats. Observation number 2. Much of the Florida panther's habitat has been taken over by land developers. Observation 3. Presently, there are few Florida panthers remaining. Taken together, these observations can lead the student to induce that the Florida panther should be placed on the endangered species list. It is a good idea to give students several examples of each type of reasoning. It may be a good idea to contrast and compare the two types of reasonings with examples. Exercises such as this one may prove fruitful in helping your students to understand the difference between inductive or deductive reasoning. For a little bit of fun, go ahead and pause the video after each question and decide, is it inductive or deductive reasoning? A chemistry experiment produces the same result 20 times, so you conclude that it will always produce the same result. Is this inductive or deductive reasoning? Pause the video now and decide. If you said inductive reasoning, you are correct. After all, we are looking at the many results of our chemistry experiment and coming to a conclusion based on the results. Let's look at another example as you would with your students. Rufus and Rose came back from the beach with sunburns. It must have been a sunny day at the beach is the conclusion. Is this inductive or deductive? Please press pause and answer. If you chose inductive, you are correct. After all, we are making a conclusion based on the evidence of sunburns. Let's do one more together. Jones will play tennis today if Smith plays. Jones will not play tennis today. Therefore, Smith will not play. Is this argument inductive or deductive? Pause now. If you said deductive reasoning, you are correct, because we have used some general information to draw a conclusion about a specific situation. You could turn your classroom into a crime scene and have your students pretend to be the detectives, where they use their super inductive skills to solve the crime. The next step is to give students a model for the process of deductive reasoning. This may look like some general steps or guidelines that apply to deductive situations. Since I teach grade 3, I've decided to use the simpler terms for young students. Have students ask themselves, 1. What specific topic am I studying? 2. What general information do I already have that might help me understand my specific topic? 3. Am I sure the general information applies to the specific topic I am studying? 4. If it does, how did the general information help me understand the specific topic? If you have older students, you may use an example like this. I am trying to determine the length of a side of a triangle, given the other two sides. I know that for right triangles, the square of the hypotenuse is equal to the sum of the squares of the other two sides. First, I have to determine if the triangle I am studying is a right triangle. If it is, I can apply the principle and calculate the length of the unknown side. To give an example from my grade 3 class last year, one student chose to research the endangered Vancouver Island marmot. One of her early searches revealed that marmots are mammals. My student activated prior and general knowledge about mammals to deduce that marmots are covered with hair or fur. Baby marmots are born alive, and they drink milk from their mother. In other words, my student was able to use general knowledge about mammals to assist in her discovery of the Vancouver Island marmot. In other words, my student made a generalization. I know that all mammals are born alive, drink their mother's milk, and have fur or hair. She then made a second generalization. The Vancouver Island marmot is a mammal. She then came to the conclusion that the Vancouver Island marmot is born alive, drinks its mother's milk, and has fur or hair. Before asking students to practice using the general guidelines for deduction, demonstrate them in a think aloud fashion, using situations which can highlight each guideline. For example, you might say, I am a weather forecaster and I see a tornado on the radar. I ask myself, what do I know about tornadoes already? I recall all the general principles related to tornadoes and determine if the tornado I'm observing has the characteristics that would make those principles apply. If the tornado does have those characteristics, I can make predictions about what the tornado will do, and I can decide whether to sound any alarms. Once students become familiar with these guidelines, it's a good idea to ask them to practice using the steps of deductive reasoning by pairing up with other students and using a think aloud technique. Providing students with graphic organizers may help them to better understand the steps involved in deductive reasoning. These organizers can be used to help students organize their information and follow carefully the steps of the process. This is one such graphic organizer. If we look in the top left corner, we will see number 1, specific situation. This provides a place for students to describe the specific situation they are looking at. At number 2, you will see spots for students to put any generalizations or principles that go along with the specific situation. At number 3, you will see the question, does the specific situation meet the conditions that make the generalization apply? If yes, then we can have an actual conclusion or prediction that is logical. If not, then we cannot draw any conclusion or prediction that makes sense. Finally, now that students hopefully have a great grasp on deductive reasoning, we can move toward teacher-structured and student-structured tasks. A teacher-structured task is very helpful, especially in the beginning when students are just learning to use the process. Through our Zoom conversation on Monday, I realized that a great majority of us are teaching the lower grades. So I really want to include an example here that even a kindergarten teacher can use. For those of you teaching the very little ones, here's an example of how you can stimulate deductive reasoning in your class. During a plant unit, Miss Isaac's kindergartners were learning about what plants need to survive and the different ways in which they get what they need. After several lessons, Miss Isaacs placed 3 green plants on a shelf by a window. She placed one plant in the middle with a brown paper bag on it. She placed the other 2 plants on either side. She explained that all of the plants would receive the same amount of water. Miss Isaacs asked students to predict what each of the plants would probably look like after a week and draw a picture that showed what they predicted. Our final topic for this lesson is teaching our students categorical syllogisms. We've been looking at many categorical syllogisms so far. It is simply an argument made up of 2 premises and exactly 1 conclusion. Let's get back to our example of Jones and Smith. Jones will play tennis today if Smith plays is our first generalization. Jones will not play tennis today is our second generalization. And our conclusion is, therefore, Smith will not play. Statements A and B are premises. Statement C is the conclusion. In everyday reasoning, the form of categorical syllogisms is usually hidden. The following argument, for example, is based on a hidden categorical syllogism. I know that Smith will not play because Jones will not play. Note that our conclusion has to be true. We are absolutely sure of it. Again, this is the defining characteristic of all forms of deductive reasoning. Given that the premises are true, the conclusion also has to be true. Categorical syllogisms tend to be very abstract, and it helps to have a graphic way of representing them. The Euler diagram, which uses circles to represent membership in a set, can make that reasoning more concrete for your students. If we take a look at this example, we see Premise 1, all animals breathe air. Premise 2, all whales are mammals. The conclusion is, therefore, all whales breathe air. In this case, let us use the picture of a cow to represent mammals and the letter A. Let us use a tree to symbolize breathing air and the letter B. And let us use a picture of a whale to represent whales and the letter C. So the three elements in this syllogism are A, mammals, B, breathe air, C, whales. If we represent each element with a circle, the first premise looks like this. In other words, all mammals breathe air, so A is constrained within B. The second premise tells us that all whales are mammals. Therefore, the circle for whales, C, goes inside the circle for mammals, A. Therefore, the entire categorical syllogism can be represented by this diagram. Finally, we need to make sure that our students examine the truth of the premises in categorical syllogisms. A categorical syllogism may be logically valid, but untrue. This occurs when the form is valid, but the premises are not true or cannot be accepted in any absolute way. For example, if we say all thieves are products of a broken home, Andy is a thief, therefore Andy is the product of a broken home, we cannot actually say conclusively that he is the product of a broken home. It may be logical, but it's not necessarily true. Well, that concludes our lesson for today. I really hope that you guys learned something and that it was helpful to you in your journey to using the dimensions of learning. It was a pleasure for me to spend some time with you. Bye-bye.